Today's lesson, section 2.1a, we'll be talking about what a function is. Okay? So, first we need to start, before we talk about what a function is, we need to talk about what a relation is. So a relation is a set of ordered pairs where the domain, which is representing the x values, or your x variable, go to the range values, or the y values. Okay? So here I have a mapping of a relation where values from your domain, which is right here, go to the range. They're all going from left to right, okay? And they're all mapping or going to a certain number. So like 2 goes to -1, 2 also goes to 4, and so you can see that I have written all the ordered pairs over here of all the x values that go to a y value. Okay? Now some double up, some go to different ones, but that's the basics of a relation, is just a set of ordered pairs. Okay? Now, just to remind you that domain is the set of values representing the x variable, range is the set of values that represent the y value. Okay? Now, a function is a little different than a relation in the fact that you can't have all your x values have to map to exactly one y value. So the rule is a rule that assigns to each element in the domain exactly one element, okay, in the range. That's how we get the f of x. That's the notation or function notation that we use to represent a function. Okay, so here's another mapping where I have a domain going to a range. Now notice that in the ordered pairs that I don't have any x values that go to two different y values. So like 1 only goes to 2, 3 only goes to -6, 5 only goes to 4, and 7 only goes to -6. Now, just so you realize this, I know that 3 goes to -6 and 7 goes to -6, but that's okay, because they're mapping to exactly 1. It doesn't matter if they're going to the same one, it's that 3 only goes to one number over on the right, and 7 only goes to one number on the right. It'd be different if you go back to this previous one, notice how 2 goes to -1 and to 4, okay? That makes it not a function. Or 3 goes to 4 and to -1, okay? That makes it also not a function. So you can't have an x value doubling up on y values. Okay? So a couple things to remember. Functions are always relations, but relations are not always functions. And a domain represents the independent variable, meaning like the number that you can change however you want. But the range represents the dependent variable because it depends on what variable from the domain or value you're picking from the domain that makes you get a certain range or a y value. Okay? Now, sometimes you'll be asked to represent a function, and there are 4 different ways of representing that. You can do it verbally, algebraically, visually, or numerically. Okay? Verbal means with words. Algebraic means writing a formula or equation. Visual means like making a graph. And numerical means writing a table. Okay? So now you'll be asked to evaluate a function, and this means that you use the function to find a value for y when you are given a beginning value of x. Now x always represents an input. Okay? That's what we said, an independent variable. You get to pick and choose and change it. Okay? But once you plug it in to your function, which is f, okay, then comes out a y value that represents what x value you plugged in. Okay? So as you change the x value, the y value will change as well. So this first one, let's, for example 1, let a of x be a variable an area of a square, where x represents one side of the square. Represent this function verbally, algebraically, visually, and numerically. Okay? So, if I was going to write, we can always start with the easy one, the formula, okay? Or the algebraic. Okay? Algebraic would be writing a formula that represents that. So a of x is the area. An area of a square is when you take the two sides, or a rectangle, right? It's base times height. Here they're saying the one side represents x. Now remember, all the sides of a square are the same, so it would be taking like x times x. So a nice easy way of representing that would be x squared. Okay, so a of x equals x squared. So that's our algebraic way of representing this function. Okay, now if I was going to do it verbally, to kind of backtrack, okay, we could say the square of a side x of a square is the area, or period. Okay? And that would be a nice easy way of representing this function. Okay, so we're squaring the side x of a square, and this is the area. Okay, and you could probably write that a little better than I did, but I'll let you worry about that. Visually, now here we can graph it. Now you don't have to box every answer, you can list them out if you want. So a graph, let's make this line up a little bit better. Okay, so there's our f of, or a of x, and our x. So here, if I plugged in 0 for my area, I would have a square of 0 area. If I plugged in 1, then I would get an area of 1, right? If I plugged in 2, I would get 4. And if you got 3, you would get 9, so it would be all the way up there, okay? Okay, so that would be my graph. Pretty simple, right? And then numerically. Now, using my graph that I just made, I can make a table. Okay, so where I have x on one side and f of x on another side, I could list my areas. And I could keep going if I'd want. So on and so forth. Okay? So those are my 4 different ways of representing the area of a square. Okay? Now I also said that you'll need to evaluate functions given a value of x. So here let's say that I want to evaluate the following functions when x is equal to -2. So that means that if f, or my x is -2, when I plug this in, every time I see an x, I'm going to replace it with a -2. It's like substitution. So I take 3 times -2 squared, see how that changes, plus -2, okay, minus 5. And then from there, I want to simplify. So -2 squared would be 4. Negative 2 is the same thing as negative 2 for the x, so there's nothing to do there. 3 times 4 gives me 12. Negative 2 minus 5 is negative 7. And then 12 minus 7 gives me 5. So f of negative 2 is equal to 5. Okay? The next thing would be if I did it for this radical over here. So f of negative 2 equals a radical of negative 2 plus 11. So inside the radical, negative 2 plus 11 would be 9. And the square root of 9 would be 3. So, in this function's case, f of negative 2 would equal 3. Okay, so depending on the function and the values you're plugging in, you may or may not get the same value. Okay? Example 3 says if f of x is equal to 2x squared plus 3x minus 1, they want you to evaluate the following, where f of a for letter A and the f of a plus h for letter B. So here sometimes they're going to ask you to plug in letters instead of numbers for your variables, which is the same concept. Okay? Now the only difference here is that you may not necessarily be able to simplify as far as you'd like. Okay? So here, if I'm going to plug in a into the x and this x, then I would get 2a squared plus 3a minus 1. Okay? Now notice there's no like terms. I can't make a into a number, so then that would be my answer. Okay? Which sometimes it would be a lot simpler like that when you're simplifying. Okay? So now here, if I want to plug in f or a plus h into my function for my x values, then I do 2 times a plus h squared plus 3 times a plus h minus 1. Okay? So then now, here I can simplify a little bit. I can square, and here I can multiply through to see what I get. So if I multiply a plus h out squared, that means I got to FOIL, or so I get a squared plus 2ah plus h squared. And if I multiply this 3 through to the parentheses using the distributive property, then it gives me 3a plus 3h. Then I also get the minus 1. Okay? And then here I can make the 2 go through. So 2a squared plus 4ah plus 2h squared plus 3a plus 3h minus 1. Now notice here I don't have any like terms, so then that would be your answer for f of a plus h. Okay? So that's basically all you need to know for this part of section 2.1. So have fun.